FSK, frequency shift keying. Frequency shift keying. The technique மட்டும் பார்ப்போம். ஒவ்வொரு டெக்னிக்கும் ப்ராபபிலிட்டி ஆஃப் எரர் கால்குலேஷன் ஃபார்முலா இருக்கு. அதெல்லாம் வந்து அடுத்த கிளாஸ்ல பார்ப்போம். ஜஸ்ட் டெக்னிக்ஸை மட்டும் இன்னைக்கு பார்க்கலாம். ஒரு 5 minutesல அது முடிச்சிடலாம். ஃப்ரீக்வன்சி ஷிஃப்ட் கீயிங்கில் ஒவ்வொரு பிட்டுக்கும் ஒரு ஃப்ரீக்வன்சி சென்ட் பண்ணுறோம். சே 0 பிட் மீன்ஸ் ஐ வில் சென்ட் ஃப்ரீக்வன்சி F1, 1 bit means I will send another frequency, say F2. So the mathematics here, BFSK, binary phase shift keying is AC cos 2 pi FCT, then beta of D from omega. That omega is indicating some frequency, some fixed frequency. Here, BT may be -1 or +1. Okay, so whenever it is 0, we may be assigning -1 number for BT. Whenever it is 1, we may be assigning +1 for BT. So at any point of time, here either we will get +1 or -1. Say for example, in our example, suppose if I am sending 0, that means what is the frequency component I will get here? That is 2 pi FCT plus omega, 2 pi FCT plus omega. Okay, then or otherwise I'll write in terms of frequency itself directly. So this is omega of t or omega t. So whenever I'm sending 0, say that is the frequency 1, that is same as omega c plus other symbol, that is also we are putting like omega. So say this is WC, then plus omega. Then F2, whenever I am sending 1, that is omega c WC minus omega. So two different frequencies send பண்றோம். 0 bit na ஒரு frequency, bit number 1 na another frequency, bit number 1 na another frequency. இப்போ இதுக்கும் நம்ம டேட்டா ரேட் கண்டுபிடிக்கணும். அது இல்லாமல் ப்ராபபிலிட்டி ஆஃப் எரரும் கண்டுபிடிக்கணும். First we'll find out data rate, and also the main condition is F1, F2 must be orthogonal. Very important condition in case of frequency shift keying. F1 and F2 must be orthogonal. Must be orthogonal to each other. சரி, இப்போ என்னுடைய ஸ்பெக்ட்ரம் வந்து நம்ம at any point of time either we are sending F1 or F2. Okay, say this is F1 center frequency. F1 is the center frequency of the signal 1, F2 is the center frequency of the signal 2. Mostly if you write the spectrum, this is because at any point of time it is carrying the data rate. So this frequency is F1 minus RB. This is F1 plus RB. Similarly, this is F2 plus RB. This is F2 minus RB. அதாவது நம்ம AM மாடுலேஷன் இதெல்லாம் பண்ணும்போது என்ன எழுதணுமோ FC plus FM, FC minus FM, அதே கான்செப்ட் தான் இங்கேயும். ஏன்னா அங்கேயும் மல்டிப்ளிகேஷன் பண்ணோம், இங்கேயும் அதே மல்டிப்ளிகேஷன் தான். So if you go just deeper, you can understand this. Okay, the spectrum will be like this. F1ல போகும்போது அதனுடைய ஸ்பெக்ட்ரம் வந்து F1 plus RB, F1 minus RB. F2ல இருக்கும்போது F2 plus RB, F2 minus RB. Now what is the bandwidth? If somebody asks what is the bandwidth, if we know bandwidth means what is the higher frequency in the system, then what is the lower frequency in the system. So bandwidth is F2 plus RB minus of F1 minus RB. So the bandwidth is F2 minus F1 plus 2 RB. Now I can compare this bandwidth with the bandwidth of AM system. Now I can compare this FSK system with the frequency modulation scheme. In frequency modulation, what is the bandwidth we have written? Anybody? 2 times of beta plus 1, or otherwise we might have written like this, say 2 times of beta plus 1 FM, or otherwise same can be written as 2 del F plus 2 FM. 2 del F plus 2 FM. So this is something similar to del F. That F2 minus F1 is something similar to del F. And then this is 2 times of, instead of FM, I am having RB. Instead of FM, I am having RB. So you can remember based on the FM equation. Straight away you can remember this formula, that is F2 minus F1 plus 2 times of RB. Now, what could be the minimum value of F2 minus F1? That is another question. What should be the minimum value of F2 minus F1? In the next page I'm writing bandwidth we have defined like F2 minus F1 plus 2 times of RB. Now, if you want to the exact value of bandwidth, I should know what is F2 minus F1 relation. What can be the minimum value of F2 minus F1? That you can read out from here. See, at any point of time, I can come here. See, there may be a gap between these two spectrum, or otherwise the gap can be very, very minimum, but there should not be the overlap. There should not be the overlap. Once if it is overlapping, the spectral shape will get disturbed. So at any point of time, both these frequency can touch together. Okay, that is the minimum value between F1 and F2. What is the minimum value between the F1 and F2? At that point, these two values will touch together. That means F1 plus RB can be equal to F2 minus RB. So that is the condition. F1 plus RB can be equal to F2 minus RB. In that condition only, I will get the minimum value, because you cannot make it as 0. Once if you make it 0, entire overlapping will be there, spectral will get disturbed completely. Then what is F2 minus F1? That is 2 times of RB. So this is the minimum possible value of F2 minus F1. So 2 RB. So bandwidth. In case of FSK, the minimum bandwidth possible is 4 times of RB. In case of FSK, minimum bandwidth needed is 4 times of RB. At any point of time, bandwidth will be definitely greater than 4 times of RB. இப்போ நம்ம இப்போ கம்பேர் பண்ண சிஸ்டத்திலே இருக்கிறதுலே இங்கே தான் வந்து என்னது அதிகமான பேண்ட்வித் வந்து தேவைப்படுது. டு சென்ட் எ பர்டிகுலர் டேட்டா, டு சென்ட் எ ஆர்பி டேட்டா, I need bandwidth of 4 times of RB. So bandwidth is much larger. Bandwidth is much larger. That means 2 times of ASK. So this is 2 times of ASK or BPSK scheme, or 4 times of QPSK scheme. 4 times of QPSK scheme. That is a major problem of using FSK system. Same signal தான் அனுப்புறோம், பட் பேண்ட்வித் வந்து நம்மளுக்கு ரொம்ப அதிகமான பேண்ட்வித் வந்து நம்மளுக்கு தேவைப்படுது. Then we will find out what is D minimum. Finally, as it is orthogonal, one I will put in the x-axis and another one basis function in the y-axis. Okay, signal 1 in the x-axis, signal 2 in the y-axis. But both will be having same energy, that is square root of EB. Okay, this is the constellation diagram, symbols in the constellation diagram. Now, what is the distance between these two? You know from the Pythagoras theorem what is the distance. X-axis distance is given, that is square root of EB. Y-axis distance is also given, that is square root of EB. If you measure this distance, that is square root of 2EB. So now this is the minimum distance in FSK. Minimum distance in FSK is square root of 2EB, square